So, good morning, guys. Um, I'll be recording uh, examples, of course. Topic today is balancing redox reaction. Redox reaction is from the word oxidation reduction reaction or the other way around. Baliktaran kasi reduction oxidation reactions. So we call it redox reactions. For redox reactions, balancing redox reactions, this is important so that we can fully or we can be familiar with how electrons are gained and lost during a electrolysis. So basically for batteries, energy inside the batteries is an oxidation reduction reaction. It's because of that. So anyway, we have example here. I've already gave you the I already gave you the rules. So I'll just anyway, you have to have your rules. You can print it out so that you can memorize it as you proceed. So I will just do it in my own way as I memorize those rules already. So I'll start with this one, letter E. So there are two types of there are reactions in acidic solution, and there are reactions in basic solutions. What it means in acidic solution, basically, acid is a reactant or a product. So it is one of it is usually one of those interacting with the system. So this is also in line or with the idea of Lewis acids and bases. So we've already talked about acids and bases. So this is more on the Lewis type. So I do believe you have already taught in your house, but if ever you do not, so just follow through for the examples because we need this one. Another thing is oh, so I'll be solving this one HNO2 and chromate. So basically I'll have my so how to solve this one? You basically first look for those substances which undergoes oxidation and those substances which undergoes reduction. And if you've already identified those, you have to split the reaction into two half reactions. We call them half reactions. The one is oxidation and the other one is reduction. So again, from the problem, you have Cr3 positive. So your HNO2, that is nitric acid or nitrous acid reacting with your chromate, and then it will produce a chromium ion 3 plus, and then another one is it will produce a nitrate NO3. So excluding oxygen and nitrogen, so basically you can see that those that probably will gain or lose is nitrogen and chromium because there's no other element here or atom here. So on oxidation, you can remember this mnemonics, Leora, that is loss of electron, we call it oxidation. So those who will be losing electron, those is undergoing oxidation. And that substance is called a reducing agent. For reduction, the fact that I can still remember it today, since it is useful. For reduction, that is Geroa. As far as I can remember, I've done this when I was still in college, and of course I reviewed. So I can still remember the Liore and the Geroa. So for reduction, that is gain of electrons, we call it a reduction. We call it a reduction, oxidation, and then reduction reaction. And then those undergoing the reduction process is we call them oxidizing agent. Oxidizing agent. So we will identify, excluding hydrogen and oxygen. So look at your rules. We will be talking about um, valence, no, the oxidation numbers. So those who will be having change in oxidation numbers, I think this nitrogen and chromium, you look at your oxygen and hydrogen. Hydrogen here will be a positive 1. Why? It is in the rules. Oxygen here would be a negative 2. So negative 2 times 2, you have a negative 4 for your oxygen. Okay, so you have positive 1 and negative 4. that would be a negative 3. So basically, since this substance must be balanced, so nitrogen must be a positive 3. So that positive 3, and then that 2 would have a negative 3. That would be HNO2 compound without a charge. Again, for a compound, there is no excess charge. But since the other one is an ion, so we will see oxygen is 2 actually, 2 negative times 2, times 7. So this 2 here is signifies the whole chromate, Cr2O7. So that 2 negative is contributing with the whole Cr2O7. So if we'll only be talking about oxygen, so oxygen here will be a negative 2. So multiplied by 7, that would be a negative 14. Okay? And then chromium here to have a 2 negative. So chromium here must have a 12, but you divide it by 2, so that must be a positive 6. 6 times 2, that will be a positive 12. Positive 12 minus 14, that would give us this negative 2. Okay, so chromium here would be positive 6. You look at your oxidation numbers, chromium would have a positive 6. But here, of course, it is already seen that it's already written that chromium would have a positive 3. So basically, from positive 6 to positive 3, you can see that chromium, what? It gained electrons because from positive 6, it becomes a negative 3. Therefore, an electron was accepted to its atoms. So basically, gain of electrons, so chromium would have the reduction process. So you can start from reduction, you can start from oxidation. I'll start with the half fraction of reduction process. So this is a reduction process. Therefore, your chromium, your chromate is the oxidizing agent. Okay? So there are only two. One is an oxidizing agent, the other one is a reducing agent. And others are not actually written, but if they are written, they will be called um, spectator ion. So sometimes, or you may not actually write the spectator ions so that it would not be hard. Okay, but anyway, here we don't have spectator ions. So you have Cr2O7, we will write it back. 2 negative, you put back the charge, and then you have Cr3 positive. So basically, from the balancing, you have to add one water molecule for every one oxygen. So since there are 7, so we will put 7 water molecules. And then for every hydrogen, for every hydrogen, you balance it on the other side. So here we have 14, so you must put 14 H plus. So this is actually the acid. This is actually the acid, H plus. So it may come from the water or from the. But anyway, that's how you balance it. What we're saying is this happens as acid is in the environment. So that's why we balance it with H plus as an acid. Okay, we balance already the. Sorry, you still have to multiply this by 2 because you have 2 chromium. Okay. So after that, you already have an atom balance, and you already have a see, you have 7 oxygen, you have 14 hydrogen, you have 14 hydrogen. After that, you balance the charge. So here we have 2 negative and 14 positive. So all in all, this will have a 12 positive. How about this here? You have 2 times 3, that is a 6 positive. How many are here? 12 positive. So you need to put how many? You need to put on the reduction a 6 electrons. Why? 6 electrons minus the 12 positive, you would have a 6 positive here. So that is also balanced with here. Okay? 6 positive. So that must be it. So this is already balanced by charge and by atoms. We go to your oxidation. Your oxidation. So of course, undergoing oxidation is your HNO2 or the nitrogen in that case. So you write all the HNO2. It has no charge, then it will proceed with NO3 negative. So again, we will balance first the oxygen. So for every here you have an excess oxygen, so you have to put water here. One water for every oxygen. You go back again to the rules. I'm not saying that you can memorize the rules, but look at the rules. So that it would not be too time consuming for me. So I'll just um, because I've already memorized those rules as you practice. So you have already oxygen, 3 oxygen, you have 3 oxygen. So the oxygen is already balanced. And then you can see that you have 3 hydrogens here. Then basically you will put 3 hydrogens, 3H plus. So again, that is the acid. So, and then after that, we will put some electrons to balance the charge. Here, we don't have a charge. Here, we have a negative 1, of course. That's the whole NO3. And then, we have a negative 1 and a positive 3. 3 times 1. So, that would be a negative 2, a positive 2. So, here we have a positive 2. So, therefore, we will compensate it with a negative 2 or a 2 electrons for it to be balanced. So after that, if this is already balanced, nitrogen is balanced, hydrogen is balanced, oxygen is balanced, now you will balance the electrons on the reduction and oxidation. You can see that they will be balanced if we multiply this thing by 3. So basically, we will multiply this by 3 because if it's already balanced, then multiplying it would still be a balanced equation. So 3H2O, then you would have a 3NO3 negative, then you would have a 9 H plus, and then you would have a 6 electrons. So basically, you can see that you have 6 electrons here, you have 6 electrons here, then you can already sum, or you can already rewrite it in a one equation. We call it the net equation, the net equation. And you also have to remember that those appearing on both sides, they will cancel out. Okay, so you have 2 chromium 3 plus plus 7H2O, and then we put a, of course, a straight line. So you can see that electrons are already balanced because that's the last thing that we did. We balanced the electrons of both sides. Then you can see that you have to cancel out some 14 here with the 9. So that would be how much? 9 plus 5. So there are 5 H plus here. Okay, as an excess. So 5, the 9 is cancelled out by this H plus. And then another one is the water. The water is being cancelled here, the 3. So this would become 4H2O. Okay? So after that, you rewrite it as much as possible with the given. So HNO2 comes first anyway, because this will again go to our learning outcomes, that the number here would be somewhat a letter, and then you that's the indication that you have balanced the equation. So how about chromate? So you would have Cr2O7, that would be how much? You have 1. You have Cr2O7, then you have a 2 negative. Then another, you have 5 acid here. So there is a, again, the acid, the H plus. Then it will produce, you write the chromium 3 positive. There are 2, so there are Cr3 positive. And then you would have the nitrate, you would have 3NO3 negative. And then lastly, the water, which is 4 water molecules. So maybe you can check. Hydrogen, you have 6 hydrogen atomically and by charge. You have 6 hydrogen, so balance. Nitrogen, you have 1. Nitrogen, you have 3. Uh-oh. So the 3 was not written, so I have to put here. Sorry. Go back to hydrogen, you have 3 plus 5, that would be 8 hydrogen. 4 times 2, that would be 8. Sorry. So that would be 8. Balance. And then next, nitrogen, you have 3. You have also 3 nitrogen here. How about oxygen? You have 6 plus 7. That would be how much? 13, 13 oxygen. So you have 9 here plus 4, that would be 9 plus 4, that would be 13. And lastly, for your chromium, you have 2. You have 2 chromium here. Of course, you have already balanced the oxygen. So lastly, you have to double check the charges. So basically, all of this will have a net charge of 5 positive minus 2. So that would be a 3 positive. So 3 positive, the whole net charge of this. And then how about this guy here? You have a 6 positive, and of course you have a 3 negative, negative 3. Negative 3, you don't have a charge here. So 6 minus 3, you would have a positive 3. So therefore, it is already balanced. So this is the balance form. So basically, you can answer that A is equal to 3, B is equal to 1, C is equal to 5, D is equal to 2, E is equal to 3, and then F is equal to 4. So that's how you balance an oxidation or a redox reaction. Okay, thank you guys. Maybe I can give you another example for the basic one. So I'll have to cut this.